All right, we have lesson 5.4, solving compound inequalities. A compound inequality is two or more inequalities that are connected by the words and or. So with type 1, let's look at an and inequality. So if we have an and, for example, we have x is greater than or equal to 3 and x is less than 7. Both of these must be true to make this inequality work. So we can also write this a second way. We can also write it as 3 is less than or equal to x and less than 7. So you read this as x is greater than or equal to 3 and less than 7, which makes our compound inequality. We can graph both of these, and then the area where they overlap is the solution for our compound inequality. So let's look at x is greater than or equal to 3 first. And we'll graph that up at the top. So we have a closed circle at 3, and it is greater than, so it includes all numbers that are greater than 3. Next, let's look at x is less than 7. Since x is less than 7, we have a open circle at 7, and it includes all the numbers that are below or less than 7. Now, if you look between 3 and 7, x can be any of these numbers. Any value can be true. So when we graph the compound inequality of x is greater than or equal to 3 and less than 7, we have a closed circle at 3, meaning that it can include 3, and an open circle at 7, which it cannot include. And that tells us that x can be any value between 3 and 7, and it can be 3. So it can be 3, 4, 5, 6, cannot be 7. Okay. Now let's look at type 2. Type 2 is our or. So if we have an or, let's look at having x is greater than 2 or x is less than or equal to negative 1. First, let's start by graphing x is greater than 2. With x is greater than 2, we're going to have an open circle at 2, and it's going to go to the right, including all numbers greater than x. Now let's look at x is less than or equal to negative 1. So we're going to have a closed circle at negative 1, and then it is less than, so our arrow is going to point to the left, including all the values less than 1. Okay, notice that there's a gap between negative 1 and 2. That's where our third graph falls into line. So if we look at that, we know that it's going to include all the values on either side of that gap. So with x is greater than 2 or x is less than or equal to negative 1, we have our closed circle at negative 1 with the arrow going left, including all the values less than. And we have an open circle at 2, including all the values that are greater than 2. That tells us that x can be any number less than negative 1, including negative 1, and any number greater than 2. So it cannot be 0, 1, or 2, but it can be any other value. Okay, let's look at an example where we have to solve a little bit more. So we're going to call this one example 1. Now that we've looked at our two types, we have to solve and graph negative 2 is less than or equal to x minus 3 is less than 4. So when we have a compound inequality here, we have to express each using the and then solving. So we're going to have negative 2 is less than or equal to x minus 3, and we're going to have x minus 3 is less than 4. So what we did was break up the inequality. So we have negative 2 is less than or equal to x minus 3, and we have x minus 3 is less than or equal to x minus 3 is less than negative 4. Positive 4. Okay, so we're going to solve the first one by adding 3 to both sides. Let's not use a highlighter here. Add 3, and that will give us 1 is less than or equal to x. Over here, we're going to do the same thing, add 3 to both sides, and x is less than 7. So we have to write our solution set for our compound inequality. So we have the set of all numbers x such that x is greater than or equal to 1 and less than 7. Okay, don't forget your teacher squiggle brackets. Okay, so let's look at this on a graph. The first one we're going to graph is x is greater than or equal to 1. So we know it's going to be a closed circle at 1, and it's including all numbers larger than 1. The next one, part of our inequality, we have x is less than 7. So we're going to have an open circle at 7, and our arrow pointing towards the left, including all values less than 7. So notice here, from 1 to 7, we have our window of values that x can possibly be. So when we graph the compound inequality of x is greater than or equal to 1 and less than 7, we have a closed circle at 1 and an open circle at 7 and a line connecting the two, meaning that all values between 1 and 7 will make this inequality true, including 1 but not 7. Okay, let's look at our next example. Here we're going to have example 2. And we are going to solve and graph negative 2m plus 7 is less than or equal to 13, or 5m plus 12 is greater than 37. So we have to start by solving each of these inequalities. So let's start with negative 2m plus 7 is less than or equal to 13. The first step we need to do is subtract 7 from both sides. That leaves us with negative 2m is less than or equal to 6. Then we're going to divide by negative 2. When we divide both sides by negative 2, remember, when we divide or multiply by a negative value, you must flip the inequality symbol. So now we're going to have m is greater than or equal to negative 3. So do not forget to switch the inequality symbol and reverse the direction if you're multiplying or dividing by a negative value. The next one, we have 5m plus 12 is greater than 37. We're going to subtract 12 from both sides. That gives us 5m is greater than 25. Then divide both sides by 5. And m is greater than 5. So we have to write our solution set. Our solution is going to be our set of all numbers m such that m is greater or equal to -3. Now, this looks a little different because we have two solutions, but our symbols are the same way. So let's look at this on the graph and see why it's just greater than or equal to -3 instead of greater than 5 and greater than or equal to -3. So let's look at m is greater than or equal to -3. We have a closed circle at -3, and it's greater, so it's including all values greater than -3. Now, if we graph m is greater than 5, we have a open circle at 5 and an arrow in the positive direction showing that it includes all numbers greater than 5. Well, if m can be greater than -3, that will also include 5 based on our first graph here. So our solution is also going to include 5, even though this says that it is an open circle and doesn't include 5. It does because of this m is greater than or equal to -3. Therefore, when we write our solution set, we just have m is greater than or equal to -3 as our solution. So we have our closed circle at -3 and including all numbers greater than -3. Okay. All right, so for your practice problems on your own, you have 4 to do. Make sure you have these completed with your notes and ready to go tomorrow morning in class.